Hey everybody, this is Larry. This is me going over Q4 of the weekly contest 491. Count subarrays with k distinct integers. Hit the like button, and subscribe button, join me on Discord. Let me know what you think about this one. So yeah, this one I am definitely weak at. It is, of course, greedy. I think there are a couple of tricky components about this, and honestly, I feel a little bit that I got 3 wrong answers because they were all unforced errors, right? And what I mean by that is that I could have easily not made them. I just kind of was, I don't know, sloppy, silly, whatever. The core idea, I think the first thing that jumps at me, right, is this idea of sliding window for this one, right? And why does sliding window work? But it's a little bit tricky because of the various portions we'll go over. But at least for me, sliding windows work because you always have to shrink the window. Like, you have a right kind of point. So for sliding windows, and people explain it different ways, but the way that I visualize it is having a left side of the window and a right side of the window, and I don't know, on video maybe it's kind of mixed up, but whatever, you get the idea. Maybe I need to mirror this or whatever. But yeah, there's the left side of the window and the right side of the window, right? And the sliding window works because when you add an element, you can make something false that you can do by that you can make true again by sliding the left side, and it represents a constraint because there's no possible subarray in which you can leapfrog the numbers, right? It's kind of monotonic in that way. So that to me is already my shoulder is still in pain. So that immediately jumps at me as a sliding window problem. But the tricky part is that you have to count them, right? And as a result, for me, there are probably a couple of ways to do this. And like I said, I did it in a sloppy way. It took me 3 tries. Is that I calculate, well, what is for each index or for each right side, what is the longest subarray that I can make? And then for each right side, what is the shortest subarray that I can make? And then with these 2 numbers, I just count, well, if this is the shortest, this is the longest, and everything in between is possible, then, that's your answer. And that's basically it. And then the other part is just keeping track, and what I call bookkeeping, keeping track of things like k distinct integers, and at least m times. And there are probably cleaner ways to do it, but, correct is correct, AC is AC, so I don't worry that much about it. But yeah, so as a result, I just have 2 functions called max left and min left. We calculate, so for each index, what I said, right, the longest you can go, and then the shortest you can go. And then you just calculate the difference, as I said, and you're good. Let's get the max left for a second. And the max left, and I call F is the frequency, right? So let me denote this. F is the frequency of each number inside the window. FF is a list sorted of the frequency, right? Frequency values, in case that's not clear. And what this does, it's allow us to go the smallest value, and maybe you could do this with a heap, kind of, maybe not, but you can look at the smallest value, which is the first element, to see if all elements are greater than equal to m, right? That's part of the problem. And that's kind of it. I slide, and when I slide, I add a number, right? And you could probably like rewrite this to be, maybe I will actually. Yeah, maybe I should have done it. To abstract this a little bit. So let's write, let's make this more abstract, right? So we have add FFF of a number, and it just basically copy and paste this part, right? Because then it'll be a little bit cleaner once we do it. Right. So then now it's just add FFF num subarray, right? So this adds a number, and then the invariant is that if we have too many unique numbers, then we have to shrink. And this is the longest, so then and then it's just we move num sub left and then left increment, right? or this, we need the prefix for a reason you'll see later. But yeah. Oh. Right. Oops. Would have saved a lot of typing too, honestly. Right. So you add, you remove, and then now, if we have enough things, and this is the part where you have to like really define your things well to go like inclusive or exclusive, right? So then it's plus or minus 1 or something. I just have like a big number here. If it's because if this is not the case, then we just don't have a number, right? And yeah, and this is left. And that's it. I mean, we can look at the bookkeeping, as I call it. It's just that, you know, we keep track of, remember f is the frequency, so we want to remove the values from ff, and then we just increment, and then we add it back in. So we just like remove. Ooh, this is wrong, isn't it? Well, I mean, I just typed this, so my apologies. But yeah, you remove this, and then this is also wrong. What is going on? This is wrong. I just kind of copy and paste and type really quickly, so that's my apologies. But now, hopefully, this makes more sense, right? And yeah, and this is removing. Yeah, we just kind of keep track of this and remove old ones as possible. And the reason why we want to do a delete is so that this can be true, right? So the number of keys, because length of f gives you the number of keys. And yeah, so you want to remove it so that you can keep track of it that way. And that's the longest thing. And then the shortest one is almost the same, right? So we'll first, we will abstract it so that we're not, because at least in terms of understanding, it's just easier to, yeah, look at it, right? I guess this could actually, now, because for example, you notice this, and you can say that, yeah, maybe you could combine them for sure, but I'm not going to. I'll just explain it, right? Basically, if this is too many unique keys, we just have to remove things. It's just a sanity check. I mean, I think that's reasonable. And I actually say it, and I forgot about this, and led to the 3 wrong answers, really. And then this one is just, well, we're trying to get the shortest, right? So that means that if this is true, then we just want to shrink it so that we get the shortest version. Until this is not true. If it is not true, then we have left. But in this case, because you want the first case that's not true, this is an exclusive bound. So remember, this is exclusive and this is inclusive. And then you just get the delta, and that's it, right? With sorted lists, obviously this loop is going to be n log n. This is all of n, and then you have a couple of remove and add functions. All of them are log n, right? Because we have a sorted list operation. But yeah, so this is n log n, this is n log n, this is n log n, and well, I mean, this is just that, so it's n log n. So everything's n log n, and everything is happy, and yeah, and that's it. And look at how much the code is cleaned up by just using this, right? You could put everything here. Just think about the invariant, and yeah, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching. It is greedy sliding window, but I think the hard part is coming up with 2 sliding windows, but which at least that was hard for me anyway. And that's it. Yeah, and you can watch me solve it live during the contest now. Okay, good. Count subarrays with k distinct integers. We have nums, k and m. Return the number of subarray. What is n? N is 10 to the 5th. Just want to make sure. Number of subarrays such that subarray contains k distinct integers, and each distinct. Oh, wow! What? How would I think about this? This seems like one of those problems with like a data structure crazy problems. So I don't know how to make of it, but constraint. Okay, nothing that we can really exploit on the constraints. Maybe this part, and maybe there's some pigeonhole, but can we do some like oh wait, at least, not exactly. Okay, that's actually, and we're given M. Okay, I think I read this confusingly a little bit. It is kind of confusing. Okay, so given M, number of subarray where, oh, exactly K, huh? So there is a sliding window component, right? Because when you get a new number, because they have exactly K distinct numbers. I think, is it not just sliding window? I feel like it should be just sliding window, right? Just because, yeah, maybe. We'll see. I mean, I might have to set this up a little bit, but right. And then here, there is some stuff that we have to think about. I mean, I think, yeah, let's just write it in a dumb way and then we'll clean it up with more data structure. I think it's possible. But okay, so here we go do. Right? Yeah. And then now, while length of f is greater than k, f of nums, so this is like just the basic structure, right? But I think we have to actually do a little bit cleaning, right? But if length of f is 0 or equals to k, then we do some stuff, right? And then we just return total or count, right? And count should be at most n squared, so that's fine. Okay, so that's the structure. I don't think that's wrong. We just have to add some more data structure to keep track. Okay, so here maybe I have a sorted list, right, of f of frequency. So then here maybe I write f, so previous is equal to right? So then now if previous is greater than 0, ff, then we remove previous, otherwise we add this, right, as the frequency. Okay. Okay, so then now while this is true, we remove, okay, so previous is equal to, if this is 0, then we do this. Otherwise, if it's not 0, we actually have to add it back in, right? And then now here, if f k could be has to be greater than 0, right? So this always exists. If this is at least m, then we do something, which is, oh, we have to count the number of arrays, right? So it's, maybe we could, can we do a binary search? So it's not the longest. If it's longest, then we're done, but count makes it a little bit trickier. How do I get the, so okay, so this is the longest. How do I get the shortest that I can get to count? This is the longest. How do I get the shortest? And you can use log n, but I mean, how do I write that? I mean, we basically do another while loop until this is false, but then we have to kind of keep track of it so then we can yeah, so then when we add a new number, that also keeps track of all these things, right? So okay, so while this is true, how do I keep track? I mean, I guess we just store it somewhere, but I'm trying to think about trying to be careful a little bit. Yeah, I mean, I think we just have to track it, really. Okay, I think like here, right? So then, okay, so new number is equal to false, and then if we're ever in here, then that means that this is true, right? So then if new, okay, so here if new number, then we keep track of previous left is equal to this, right? Okay. Okay. Left boundary maybe? I don't know. All right, let's wait. Okay. And then now we do a while. Right? Then now we also move left. So maybe we could copy some code here, but yeah. Yeah, I think it's just copy and paste for now. Yeah, I don't want to. Maybe we could abstract it. I don't know, but yeah. Okay, so then now this is the first case. So then it's going to be something like left minus previous left. It's going to be the answer. Because the left is the new boundary, right? Is it +1? No, because this left should be past it, right? Oh, if it's none. That's the thing that I thought there's an invariant that this is always going to be none, but oh, the first instance is going to be the new number is true. How do I get the first instance? Yes, first instance is just 0 then. Yeah, if we never had more than whatever. Okay, that's not great. Oh, this is while this, but no. That doesn't make sense though. We moved. Okay, so oh wow. But this should that command under, right? So that means something is really wrong for now. So if this is true, right? Let's just print this real quick. We start this. So it's going. Okay, so we move this. Oh, I see. So I guess we have to. While length of f is equal to k, because or this, right? Something like that. Because then it should be 0 really, but is it n? Yes, it's an n actually. All right, 1 and 6, which is very wrong. Let's see. So we have right, left, previous left, right? So on index 3, left is 1, this is 0, that's good. But then what the next one? The next one, is this not true? It goes up to here. Oh, no, wait. Yeah, because when you add this, it doesn't go back to the thing. Huh. It doesn't count the oh, actually, no. This actually should just go on all of them, not just this. Assuming if length of f is equal to k. Meaning that we have enough numbers. No, even that's not true. I mean, because we couldn't remove numbers in a way such that it is less than 1 or less than whatever, but just have to make sure that it gets triggered once, right? So if this ever good is equal to true, good is equal to false, then this will always have some stuff. So then here, as long as triggered more than once, I think this is fine. But I think now we have to part 2 or example 2 is wrong then, right? I don't know why we moved it. So 1 1 is gonna be 1, 2 is gonna be 2. That's not right, right? 2, we don't update the previous left. Why? But this was true, right? Oh, this is messed up because then now length of f after adding the numbers, so the two invariants don't mix. Wow. Huh. My invariants are already messed up, as you can see. Okay. I don't think I could just hack it like this. I have to, let me step back and think. Okay, so how would I even write this then? I mean, I guess we just have to keep track of two things. We keep track of the min boundary and the max boundary, the longest boundary and the shortest boundary at the same time, I guess. Okay, fine. Maybe that works. I don't know if that works, to be honest. But yeah, okay, fine. I'll give it a try though. Okay, let's just do. Okay, let's quote this first, just to make sure that this is at least still right. Okay, so then now, if this is true, then we just track it, right? Okay, so right. Answer that append left, else so just so then it's not possible. Then we just append -1 for now, I guess. I don't know. Maybe just say n for now, right? Let me print it out real quick. Unexpected indent, that's probably true. Only really, I mean, I still want to keep that code, just not there. Why is it so annoying? Oh, I guess actually this is fine. Okay, so 5550, is that right? Oh, a 5 is infinity. So then here, okay, so that's right, and what we want to do that. This is just n. Maybe I should, instead of n, I do infinity, so it's very clear. But okay, fine. 0 1 2. Okay, so that's right, and then now we can just long left, right? And now we do this. So then here, that's for long left. L left is equal to long left, something like that, right? And then here we have maybe max left and min left. Maybe that's what I should have called it. Oh well, it's too late. Yeah, it's fine. And it's going to be mostly the same structurally, except for now. This part is, yeah, instead we go, yeah, this part, maybe, hopefully. not super certain about it at this point, honestly. Okay, so then we have this, right? This is the min left. So while this is true, so then now I think we just do left, maybe, right? Let's print it out real quick. What? Oh. Weird. Is that true? That doesn't make sense. This cannot be that left is equal to 0. We remove. So then if we remove everything, this has to be false. So what's going on? Huh? Index, list index, why? Delete it. Huh. Huh? If this is true, then this has to have something. Right? No, left could be exactly no, I guess. No, because then this thing would just be false if left is greater than, if left is equal to right plus 1. What? Why? That's weird. Okay, so this is on. Oh, well, I'm just dumb because I don't know why I had it out here. It should be inside. I thought I had it inside, but then I just noticed that. Yeah. Okay. So then now it goes 0, 1, 0, 1, 1, 2, 3. Yeah. Okay. So then now, yeah, count is equal to 0. I know that we initialize it, but whatever. Min max in zip of min left, max left. Count we added by yeah, I think that's fine. Yeah. Did I mess that up? Min, max. This is max. This is min. So this should be just 2, right? 1 minus. Huh? How did I? Am I bad at math that badly? What? How did it get to 15? And 4. Huh? I mean, 15 is like maybe. Oh, did I just do it the other way? It's my max. Max left is the leftmost. So this is the max and this is the min. I see. I guess max and min is a little bit confusing for me, the way that I wrote it. But I'm just gonna admit. Okay, looks okay. It's linear, so well, no, it's n log n. But we'll see. I don't expect this to be right. But I feel like because these kind of greedies is very tricky. I feel like. But yeah, okay. So I mean, this is clearly wrong. So k is equal to 1. What is one unique number? So so this is 1 and this is 1. I think k goes to 1 may. I mean, I'm not surprised that it is wrong per se. Oh, this is kind of weird though. But why is this wrong? Oh no, because it's 1 and 2. 2. Okay. What does 2 mean? Here. 2 means that it goes. What? I'm confusing the max and the min notation, but okay. So here, maybe I just. I mean, I I think one thing that I'm trying to figure out is whether k equals to 1 is a special case, which we can figure, and we can special case it, right? This is easy to solve. But then now I'm like, well, like if I submit this and let's say I have to write code here, would that be enough? Or am I missing like a more general idea? So that's why I'm hesitating, because we can definitely do this. And it is possible that k equals to 1 is a special case because of the way that I handle like stuff like this is a little bit awkward for sure. So maybe I'll give it a try, right? Yeah, then proceed in nums, right? So streak is 0 to 0, count is 0 to 0. So yeah, previous 0 to none, right? So if c is equal to previous, then streak increment by 1. And then just count is equal greater than streak minus m plus 1, but not negative, right? Else, and I think this is actually whatever anyway. Else streak is equal to 1, previous is equal to c, and yeah, and that's it, I think, actually. Right? Yeah, maybe. Yeah, so fixes it. I think this is a special case that I didn't really, maybe I should have considered, but what did I change? Why is this? I mean, I know that did I like undo too much or something? Yeah, I don't know how that happened. I think maybe I just clicked on undo or something, and then it, because it clearly, as soon as I submitted, I noticed it, but then I don't know. Okay, still wrong answer though, so it's not just that. I don't know. That's a mess. Oh, they have a big number, but that shouldn't be a matter. Okay, m is equal to 2, k is equal to 3. What's k again? K is the number of distinct numbers, and where m is equal to 2. So yeah, basically this. But I think I undo to get the print statement, but then I undid extra stuff by accident. Anyway, min left. Maybe this is not the right way. Like, I'm not super confident about this idea. But yeah. What is my invariant? So this is going to be 0. As in... this 0 is a little weird. This one is actually correct. So, so the max left is correct, but the min left is wrong, I think. Okay. So what's the min left? And that's what I was talking about with this case. I was like, I don't know that I'm confident that that's enough. But, and I made an extra typo anyway. But, okay. So here, this is wrong. We had this. So this is true. Right? At the last element, this is true. Right? So why oh, I'm dumb, right? Because now length of f is greater than thing, right? So okay, I guess how did I miss this? So we still need this, but we just don't. Also, we don't need a new number thing. So we definitely still need this because it just makes this not possible, right? So, yeah, maybe this should have been an or, but okay. This still looks right for the other ones. This time I'm a little bit slower because I YOLO submitted, even though I noticed these two are wrong. Okay. I mean, that's an obvious fix. I don't know if it's enough, but it's an obvious fix. Like, I don't know why I removed it. I think I just kind of got caught up on the asymmetry of things that I kind of got confused. But we definitely need to, right? Because length of f can be greater than k. I don't know why that was like test case 900, because this should have been wrong for a lot of things. But yeah, I mean, one of the wrong answers was just me not reading the example. K is equal to 1. I'm curious whether this actually fixed the k is equal to 1. I just, like, maybe that was just me being dumb. And maybe it was, yeah, huh. Yeah, so I didn't need the k is equal to 1. I just, but that's a tricky thing, right? Was that I could see that k is equal to 1 could be a special case. And that's why, but I wasn't confident enough. And it turns out that I just forgot about this, because you need this to make sure that this was even possible, right? So yeah, so that's kind of that's a silly mistake on my part. And you could obviously abstract parts of this. I mean, this is reused here anyway, but that's, you know, not a big deal. But yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem, this contest, everything in between. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.